we will be solving radical equations today. So equations where you have a radical with a variable inside, so a variable as the radicand or part of the radicand. And I did give you some like this yesterday. But here we have the square root of y minus 1 plus 7 equals 13, and we want to figure out what y is. First step up there says isolate one radical. This only has one radical, which makes it actually a lot easier to do than the ones that have two. But it says isolate that radical. So I'm going to do that by subtracting 7 from both sides of the equation. And I get the square root of y minus 1 is equal to 6, because it's 13 minus 7. If you remember, when you're solving equations, not quadratics, but anything linear, the way that we solve them is by isolating the variable, and we do that by performing opposite operations. So in the first one, we had this plus 7 we wanted to get rid of. We do the opposite of adding 7, which is subtracting 7. It gets rid of it, and you do the same on the other side. Well, now we have this square root sign that we want to get rid of. And what's the opposite of a square root? Square, right. So the second step is square both sides of the equation. So I'm going to go like this and square this and square this. When I square the square root of y minus 1, I end up with y minus 1. And when I square 6, I get 36. The third step says repeat steps 1 and 2 until there are no radicals left. Well, I already don't have any radicals. If I did still have a radical, then I would need to isolate it and square again. You will see a few like that, but not, most of them will be more like this, where you have just one radical. But that is the next step. If you have any more radicals, you need to isolate them and square again. And then step 4, solve the remaining equation. So you're going to have to look at the equation that's there and say, is it linear or is it quadratic? And then decide how you're going to solve it. This one's pretty easy to solve. It's linear, so just isolate the y. Add 1 to both sides. And we get y equals 37. And that's the answer. But there are 2 other little parts that we need to do, which are these steps 5 and 6. Consider the restrictions on the variable and verify the answer. And the only restrictions when you have something like this is you can't take the square root of a negative number, right? We know that. So if your answer came out to something where you'd end up doing the square root of a negative number, you'd have to look at it and go, oh wait, that doesn't work, that can't be an answer. And we'd call it an extraneous solution. But there's no reason why you can't take the square root of this. And so to verify, I'm just going to put 37 in for y. So it's the square root of 37 minus 1. Which is 36, square root of 36 is 6, plus 7 is 13. It works. So that is the answer. Here's another one. Step 1 was isolate the radical. The radical's already by itself. It's the only thing that's on the right-hand side. So all we need to do is the second step, which is square both sides. So square that. And square that, and I get, well, m squared. And then the squared on the right just cancels out the square root, so it's 2 minus m. Now I don't have any radicals left, so it's just an equation that I can solve. Do you know how to solve that? What type of equation is it? It's quadratic, right. So to solve a quadratic, we don't isolate the variable. We put everything on one side and then solve either by factoring or using the quadratic formula or something. There were a couple other options, but so I'm going to add m and subtract 2. Now it's ready to solve, and I'll factor it to solve. let's see, m plus 2, m minus 1. So m equals negative 2, or m equals 1. And then I need to check those answers to verify. I don't see a problem right off the bat with either one, but let's have a look. If I do negative 2 equals the square root of 2 minus negative 2, then I get negative 2 equals the square root of 4. This is just verifying the negative 2. And what's the square root of 4? So I get negative 2 equals 2. What does that tell you? It's not. That's what we call an extraneous root or an extraneous solution. Extraneous right there. We'll try the 1. So if we try the 1 equals the square root of 1. That one works. This one didn't, this one does. So this has just one solution. Even though when we solved the quadratic, we came up with 2 solutions. Here's the last one that we're going to do. This one is trickier because this one has 2 radicals. And the first step, remember, is isolate one of the radicals. Well, this one is already isolated, so I'm just going to go ahead and square both sides. But this is where it gets kind of tricky. When I square the left, I just get 2x plus 5. But what happens when I square the right side of that? Here's what you need to think about. It's equal to squaring 2 root 2x plus 1 is the same as multiplying 2 root 2x plus 1 by itself. So we actually have to use the distributive property and multiply that out. That's why this one's going to be trickier. So we'll do 2 root 2x times 2 root 2x, which is 4 root 4x squared. And then plus 2 root 2x plus 2 root 2x and plus 1. So this gets a bit messy. I need to simplify and combine terms and see what I'm left with. I'll just leave the 2x plus 5 alone for now. This 4 root 4x squared is actually equal to, well, this part here is the same as 2x, right? So that's 8x. I just took the square root of 4x squared. Square root of 4x squared is 2x. So multiply by 4, 8x. These next 2 terms I can combine, so that's 4 root 2x, and then plus 1. So we're at this point where we've simplified everything on the right-hand side, but do you remember what step 3 was? Who wrote it down and can tell me what step 3 is?
Repeat steps 1 and 2.
Right, repeat steps 1 and 2 until there are no more radicals. We still have a radical here. So now we have to isolate that radical and square both sides again. So let's subtract 8x, so that's negative 6x, and we'll subtract 1, so minus 4, and then 4 root 2x. Now we have that radical isolated, and now we can square both sides again. Oops, I need to square that and square that. When I square negative 6x plus 4, it's negative 6x plus 4 times negative 6x plus 4. So that will be 36x squared. Right? And then minus 24x minus 24x and plus 16 equals, and now when I square this 4 root 2x, I square the 4, that's 16, and I square the root 2x, and that's just 2x. Because the squaring, it just cancels out the square root sign. Now it's a quadratic equation, so I'm going to be able to solve it. It just still needs a little bit of work. This is actually, if I multiply it out, that goes to 32x. So we'll do 36x squared. I'm going to combine all of the x's. And I get, so negative 24 and negative 24x. And then I'll also subtract the 32. So I end up with negative 80x plus 16. And then I need to solve that, and I'm going to solve by factoring. Take out a common factor first of 4. Factor it, and then you get x equals 2 over 9, and x equals 2, and I need to verify both of those solutions by filling them back into the original. When I check them both, I find that this one is extraneous, so we only have one solution here, which is the 2 over 9.